All right, guys, welcome back. Today we are going to go over the difference between a chemical change and a physical change. And although this seems like this is an easy concept to understand, it's often a lot more difficult than it seems. So let's go over some basics to start. Let's look at water as our first example. Water is something that we are all familiar with. We see it in the solid, liquid, and gas state. So here I have a Lewis dot structure drawn for water. It's important to understand the difference between a bond and an intermolecular force. So let's start out by identifying which is which. All right, a bond holds two atoms together for the purpose of stability. So the O and the H here are bonded to one another so that they both have a full outer valence shell. That bond is all about stability. Now, if we break that bond, that is when we end up with a chemical change. When we have a physical change, we are not breaking bonds. Instead, we are breaking the intermolecular forces that are holding two separate happy water molecules together. We know that water is a very polar molecule. There are big differences in electronegativities between the O and the H, causing a shifting of the electrons. So what we see is that the positive end of a one water molecule, the hydrogen, will attract to the negative end of the next water molecule. So there will be a slight attraction there due to those opposite charges. That attraction is an intermolecular force. When we break an intermolecular force, that is going to result in a physical change. So depending on what we are breaking within the molecule, whether it's the bonds or the intermolecular forces, that's going to dictate whether we have a chemical change or a physical change. Because we can't see the molecules visually, we have to know what is happening in a chemical change and a physical change based on what we see. An easy way to think about this is that in a chemical change, we make something new. In a physical change, we have the same substance before and after the change. Let me show you what I mean using the Lewis dot structures for our waters above. So if I were to break this intermolecular force, when I break that intermolecular force and I separate these two from one another, notice that I haven't changed the fact that I have water. I have water or H2O before and after I break the intermolecular force. But if I have a chemical change, that would involve breaking these bonds. And if I break the bonds, I've now separated the O's and the H's, and because they are separated from one another, I have made something new. So a chemical change always results in making something new at the end, whereas a physical change has the same substance before and after. Let's look at a few examples here. Melting ice is the first example. So when you melt ice, you have a solid ice cube, which is made of water, and after it melts, we have a puddle, which is still water. We haven't changed the fact that we have water before and after. Because it's water before and after, we have not made anything new, and therefore this is an example of a physical change. Now, if I burn paper, when I start with the paper and I burn it, I end up with smoke, I end up with soot, I end up with ash, I end up with new substances that weren't there before. Because I'm making something new, that indicates that this is a chemical change, and therefore we broke bonds in the process. Another example is crumpling foil. If I have a sheet of aluminum foil, it is aluminum when I start and it's flat. If I crumple it up, at the end, I haven't changed it. I haven't made anything new. It is still aluminum in the end. Therefore, this is an example of a physical change. Let's look at an example of a nail rusting. That nail is made of iron, but after it rusts, my iron, which was once shiny and silvery and metallic in nature, is now red and crumbly and brittle. I have made a new substance. Because I've made an entirely new substance, this would be classified as a chemical change. One of them that I think is the trickiest to understand is dissolving salt. So when something is dissolving, it's important to remember that an ionic compound like NaCl, for example, table salt, when you put that in water, the NAs and the Cls separate from one another. But we have not chemically changed them. If you think about how salt tastes if you were to just eat a few grains of salt, versus if you dissolve it in water, it still tastes like salt. we have not made anything new. And because we have not made anything new, that indicates that this is a physical change. When we are in a lab, there are some important indicators that we can look for to identify if we've had a chemical change or a physical change. So let's focus in on some of the signs of a chemical change. First, an unnatural color change. So, for example, if I have some red paint and some blue paint and I mix them together, they make purple, that's a natural color change. But if I have a clear liquid and I have a green liquid and I pour them together and they make something purple, that is an unnatural color change. That's a sign that we have made something new, and therefore that would be a chemical change. Another sign of a chemical change is gas production. So if we see something fizzing or bubbling, we know that gas is being produced and given off. That gas was not there before, therefore we have made something new. So gas production is a great sign of a chemical change. The release of heat or light. For example, if I burn a piece of paper, the heat and light given off indicate that I am making something new. Precipitate formation. Precipitate is just a solid that falls out of solution when you mix two liquids together. So if you see that new solid fall out of solution, that would indicate that you have made something new, which is a sign of a chemical change. The last thing that's a good indicator that it was a chemical change rather than a physical change is a change in smell or a change in odor. If an odor appears that was not there before, that's an indication that we have made something new. Another helpful hint when trying to decide if something is a chemical change or a physical change is that chemical changes are not easily reversed. So for example, if I crumple a piece of paper up, I can easily uncrumple that paper up. It's a reversible change. But if I burn a piece of paper, it's not easy to take that burnt paper and change it back to its original form. So that's another great indication that you have a chemical change. Hopefully this helped clear up the differences between chemical changes and physical changes. Please check out my other videos, and thanks for watching.